Okay, solve for x and double check the solutions. Okay, the given equation contains one absolute value, only one absolute value. So we have a strategy to solve such an equation. So first we isolate the absolute value, then we'll get, then we'll, in the first step, we'll get an equation of this form. We isolate the absolute value. So this will be something, right? We need to find this expression. And then what do we do in the second step? We break this equation down into two equations without any absolute values. Okay. So and then we solve the two equations. Right? That is our strategy. So the first step, to isolate the absolute value, we have to remove this term out of the left side. So we subtract 1 from both sides. Okay? So we get absolute value of 3x plus 2. And this 1 and this negative 1 are cancelled out. And on the right, we get 6 minus 1, which is 5. So we isolated the absolute value. And in the second step, we break this equation into two equations without any absolute values. So we think of this in this way. So when is this equation is satisfied? That is when 3x plus 2 equals 5, or when 3x plus 2 equals negative 5, right? So now these equations are linear equations, so we know how to solve them. We isolate the variable x. So we solve them. So the left one first. So to isolate x, we have to remove this term first, 2. So we subtract 2 from both sides. So we get 3x equals 3. And then we need to remove this factor 3. So we subtract, oh, I'm sorry, we divide by 3. We divide the equation by 3, right, to remove this factor. So on the left side, these the three, these threes are cancelled out, so we get x. And on the right side, again 3 and 3, these are cancelled out, so we get 1 over 1, that is 1. So this is one solution. And now the equation on the right. So we do the same thing. We isolate the variable x. So first we have to remove this term. So we subtract 2 from both sides. Then on the left we'll get 3x, and on the right we get negative 5 minus 2 is negative 7. And then divide both sides by the factor of x, I mean the coefficient of x term. So we divide by 3. So we get x on the left, and on the right, negative 7 over 3. So we found the other solution. So there are two solutions, 1 and negative 7 over 3. So now the second part of the question asks us to double check the solutions. So we need to check these solutions, the two solutions. So how do you check the solutions? We plug in the numbers into the original equation and then check if the equation is satisfied or not. So x, so checking. So we check when x equals 1, we see what happens. When x equals 1, if we plug in 1 into the equation, we get absolute value of 3 times 1 plus 2 plus 1 equals 6. What do we check? If we check if this equation is satisfied. So if the left side is the same as the right side. So it's trivial, right? Here, 3 times 1 plus 2 is 5. So absolute value of 5 is 5 plus 1, which is 6. So the left side is 6, the right side is 6, so the equation is satisfied. So x equals 1, I mean 1 is fine. It's a solution. It's a right solution. And when x equals negative 7 over 3, we plug in negative 7 over 3 into the equation. So absolute value of 3 times negative 7 over 3 plus 2 plus 1 equals 6. So we check if this equation is true or not. But here I need to mention this. When you plug in a negative number into a variable, we need to put that number, that negative number, in the parentheses, right? So you have to keep this in mind. So then, what is this number? 3 times negative 7 over 3 plus 2. So we multiply 3 and negative 7 over 3. It's a product of a positive number and a negative number, so it's negative. And this 3 and this 3, one is in the numerator and the other one is in the denominator, so they are cancelled out. Negative 7, right? So negative 7 plus 2. That's the absolute value. Plus 1. This is the left side. And negative 7 plus 2 is negative 5. And its absolute value is 5, right? So the left side is 5 plus 1, which is 6. So that means this equation is satisfied. This equation is true. So negative 7 over 3 is also the right solution. So we check the solutions. Thank you.